All right. Hi, everyone. Welcome to the Introduction to AI webinar. We are just getting folks logged in, so we'll just give it a few minutes here. But as we get settled in, not a few minutes, a few seconds. So we have time. We don't have a lot of time. We're going to get through this. But I want to thank you first and foremost for being here. My name is Emily Laird. I'm from the University of Wisconsin-Stout. It is such a pleasure to have you. I will talk as we get into this about all the incredible things we're doing here at the university, and I'm so pleased to be joined by my colleagues. So again, we'll just kick this off. So welcome to the introduction to our AI webinar. And my name is Emily Laird. I'm the AI integration technologist at the University of Wisconsin-Stout. I'm also a lecturer here. I teach technical writing and communication. I also teach AI courses. So my main one is writing with generative AI. And so with that, I'm going to have our esteemed colleagues kick it off and also introduce themselves. Keith, I'm going to go ahead and start with you.
All right. Thank you, Emily. So hello, everyone. I'm Keith Wojciechowski. I'm a professor of applied mathematics here at UW-Stout. So I do have my PhD in applied mathematics. And so that means that I like to solve problems, essentially. And I just learn whatever tools I need to solve those problems. And one of those tools that I've learned in the last, I would say, 7-8 years is machine learning and deep learning in combination with all the other computing tools that I've managed. So let me get started. I'm going to do the introduction to artificial intelligence. And I'm going to take you through what that means. So like, what is artificial intelligence? And one of the things that I want you, or three of the things I want you to think of is like, kind of who thought of this idea? Where did this come from? And then how does, when we say we're going to make a machine smarter, how do we do that? And then how does a machine perform tasks? So anytime you're using AI, you'll see, you may want to keep reflecting on those questions. So I think most of the time people think of artificial intelligence as just things like Perplexity or ChatGPT or Claude, but it's actually a lot more than that. It's much larger than just generative AI, which you'll see is actually a small part of the puzzle, kind of the center. So some people think this is a recent phenomenon, like maybe this just came onto the scene in 2022 when ChatGPT came on the scene, but it's actually been around a very long time. Some people think that it goes back to Alan Turing's 1950 paper on computing machinery and intelligence. Some people think maybe it was started in 1956 with the Dartmouth workshop, which they call the Constitutional Convention of AI. And that's where John McCarthy coined the phrase artificial intelligence. And something I would like us to reflect on is when he coined that phrase artificial intelligence, he also said something I think rather profound after he coined that phrase. He says, as soon as we realize artificial intelligence, we should stop using the phrase artificial intelligence and just make it something that's like just integrated into our work life and our personal lives. But I would like to say that I mean, some people might argue that artificial intelligence really started even long before that, maybe with Charles Babbage and the computing machine, or Ada Lovelace, one of the first computer programmers. Some people could even go back to the 4th century BCE, where Archytas of Tarentum made a steam-powered pigeon, or came up with the idea for a steam-powered pigeon, didn't make one, but came up with the idea for it, which he called the pigeon. Leonardo da Vinci, around 1495, made sketches for a mechanical knight. And these were like some of the first ideas of coming up with robots and the idea of having a machine start to do tasks for people. And 1939, in the World's Fair, there was Electro the robot. And then, all the way to today, we have, surgeons who use like the company Intuitive Surgical, and we have surgeons who actually use what they call the Da Vinci surgical systems. And these are, of course, built and designed with reinforcement learning and machine learning and AI at their foundations. So this has been around. So the point is, this has been around for a while, and it's been rather pervasive. And I just don't want you to think like it's a recent phenomenon. Okay, so what do we mean by the field of artificial intelligence? Well, it's multi-layered. So on broadly speaking, artificial intelligence, we could think of this as just like this, Venn diagram, but everything's contained within it. And within artificial intelligence, we have all the things that you need to basically build artificial intelligence, like machine learning, neural networks, and deep learning, which some people consider machine learning, neural networks, and deep learning to be all just one thing. So just so you're aware of that. And then at the center of all that is generative AI, which is probably the tool that we use most commonly every day. I'll come back to this diagram momentarily. So I'm going to start with the most familiar and then kind of work my way to the least familiar. So generative AI is what you probably have used in generating images, but also, coming up, developing chatbots or using chatbots, using it for writing emails and such. But I wanted to give a couple other use cases that you may not be familiar with, and I'll share kind of like how I use it. So, for example, if I'm doing any type of computer programming, or developing a machine learning model, I will oftentimes there might be something I might forget how to do, or there might be something that's rather tedious to code, and it takes 10 lines of code to do, and I don't want to sit there and have to redo it or just copy and paste it, or there might be some minor tweaks I have to make to it. I might use something like Perplexity to generate that code, and then I can modify it afterwards, very much like you might do with an email. So we use it for code autocomplete and code generation. We can also use it for data augmentation for training models. So sometimes it's very difficult to get data. So I'll give you an example from my experience. I've worked with the agricultural industry here in Wisconsin, and I might be doing some work with some growers on doing yield prediction. And so we need to generate data. And you can imagine, if you're trying to get seasons of data for a crop that isn't well studied, we can't wait 10 years to get that data. We might only have a year's worth of data. And so we might do some synthetic data generation using generative AI then to fit our models and make some kinds of predictions. Another place this shows up is in balanced data. So sometimes when you're studying a data problem, you might have something like credit fraud or diagnosing diabetes, where a small population, right? Not many people, are experiencing credit fraud, fortunately, or not many people have diabetes. But when you're studying that data set, if the computer were just to predict no one has diabetes, it might actually be 95% accurate. But that isn't the truth, right? I mean, we want to be able to make those predictions when someone has diabetes or not. So we have to do something called balancing that data set when we're making those predictions, so that when the computer is learning, it sees a little more parity in the data. So those are some of the more sophisticated uses of generative AI that a lot of people may not necessarily think of, and I just wanted to kind of spur on your imagination for that. And then there's natural language processing, and here I'll give it a couple more examples, and because this is where you might have used it, like with Google Translate, for example, or the text summarization voice, or Notebook LM, for example, in creating podcasts to learn about. Maybe you're trying to plan for a vacation and you want to get all this information on going to Italy or something like that. You can actually use Notebook LM to then generate a podcast that can summarize all that information for you. That uses a natural language processing model. So, but this is also used a lot of times in the medical field for automatic clinical documentation. So if you want to extract and structure data from handwritten notes, or you might identify critical patient info and code it for prescription or for billing and insurance. And then, of course, for any type of literature, like if you're studying, journal articles, you can summarize those articles. So this is where something like natural language processing, which you might see is abbreviated just with the acronym NLP, comes into play. All right. So that's just a generative AI part of this diagram. And now I'm going to expand out. I'm going to start with the machine learning, and I'm going to come back down to neural nets and deep learning. So let's start with machine learning. This is how we actually make the machine smarter when we say we make the machine smarter. And the use cases for this you can see listed down there for, like, like I said, anomaly detection, making your recommender systems with anytime you've used, so for example, YouTube or Amazon, and you've gotten recommendations. This is how they've done it. They've used machine learning in the background to make those recommendations. But let me take you through briefly the what the process looks like. And I'm going to keep it kind of I will keep it math light and coding light. But here you might have what you see is blue dots or yellow dots. So you see two sets of dots on the screen. And we as humans can just look at that and come up with a way to distinguish one group from the next. But how do we get a machine to do that? That's the difficult thing, right? And the term machine learning is actually rather descriptive, because the machine is going to learn how to do that. So it might make an initial guess and put what looks to be, you see that line in the middle, which it looks like a street with a center line. It might put that line right in the middle and say, okay, I'm going to make an initial guess. And then it's going to calculate an error based on how many points did it sort from the left or from the right. And it will then iterate and drive that error down and try to minimize that error until it says, okay, I've sorted it as best I can. The two dotted lines are what we call the margins. Some people call those the gutters. And that is, you try to do it to keep as many points out of the street as possible. And that's kind of like your margin of error. You could think of it loosely speaking. So this is how machines, for example, could potentially learn to sort out two groups. And what you see there on the left is just some Python code, just so you see what does that look like. And this is actually the diagram you see there was actually generated with just that small amount of code. But inside of that is this package. And if you see that SVC there, that's a Python package. Python is a programming language that we use for machine learning. That has a lot of these tools already integrated into it. So it's tools within tools within tools. So this is how the process typically works. You start out with your data acquisition, you clean up your data, and then just like we would as students, how humans learn a lot of times is we look at training problems like our homework problems, and we train the model. And off to the side, we might have a test set that we're going to test ourselves on later. We train the model, we test our knowledge, we test the model's knowledge, it comes back and it keeps retraining. And that's an iterative process. That's why these things take such huge computing power. So if you hear things like OpenAI or Meta, and they have these, these server farms, and they're using a lot of supercomputers to train these models. This is the process where all that computing is intensive. And this is one of the reasons why you've seen artificial intelligence kind of jump on the scene recently, is because we've only recently, within the last 15 to 20 years, we're able to get this level of computing power to solve these types of problems. Once the model's been trained, now we're ready to test the model, just like students, right? Once they've done all the homework problems, they can come back and they can actually take the test. And this is where we test our model and we say, is it good enough? Is it going to reach the level of accuracy that we need? If it is, we're going to deploy it out into the field. So that's the typical machine learning and deep learning process. So that's when we say machine learns, that's what we mean by learning. Other types of machine learning models, the next two are very similar to one another. They're just levels of advancement, okay? So there's things we call neural networks. The original machine learning model I showed you at the beginning is, it just has what we call one cost function that computes the error and then drives the model. And this one, we actually dispatch a whole network of functions to that we're going to train. So hence why it's called a neural network. These are used, of course, right, in things like facial recognition or in image and speech recognition. I'll show you an example at the end. And I'll give you, actually, I'll hold off. I have a good example I'll come back to later. And then there's deep learning, and this is just really just a matter of architecture. This deep learning is also a neural network, but it has many, many more layers to it, many more, the network is much more larger. And so that's why they call it deep learning, because you're getting deep into the layers of the network. And these are the things where you can do very much like image and video recognition or generation, and then medical diagnostics for predicting things like with MRI scans, you might be, or with X-rays, you might be trying to predict something like multiple sclerosis, or you might be trying to find cancer in patients and such. And then finally, there's computer vision, which oftentimes relies on, this is really, I think of this more as a use case of deep learning and artificial networks. But in computer vision, for example, this is where we may use things like drones, and we send drones out over, for example, if I go to the agricultural use case again, we might send drones out. They'll take pictures of, or the drone cameras will take pictures of the field and identify, for example, if there's weeds in the crops. And then you can actually use the drone to deploy the weed killer at that specific weed. And it can have the type of weed killer that it's going to use for that specific weed. So that's an example of where you might use something like computer vision, or you might have computer vision deployed in a manufacturing application where you are trying to look for defects in a product or a produce, for example, and you can reject those items from, off a conveyor belt, or if they're dropping down, if you have like an electric eye that might see like a bean that is defective, and then it can use a puff of air to push that out of the system if you're processing something like kidney beans or soybeans or black beans and so on and so forth. All right, so here's again another example of what a network looks like. And the thing you see on the left, that's the code, and those linear 1, linear 2, linear 3, those are, for example, the layers that are dispatched across the network. And here, this is a little code that I wrote some time ago, where I'm trying to predict if something is, a cat, a bird, a dog, a deer, whatever. It's just going to look at the picture and it's just going to make a prediction. What is it? You can see the ground truth at the top there of the pictures, the image on the left, which has been compressed severely. That's why it looks so blurry. That's a cat. Next, we have a ship. Next to that, we have a ship. And then we have the Concorde, we have a plane. Now, if you look at the bottom, the code I wrote, for example, it predicted the first thing to be a dog, so it made a mistake. It thought the ship next to it was a car. Okay, so it made a mistake. That's fine. But then it got the next two right. And that's something to keep in mind. When these things aren't going to be perfect, just like we're not perfect. They are going to make mistakes. And you can also figure out at what level of accuracy is it going to be able to make these predictions. And you can see, like on the right there, I have a little chart. The accuracy of predicting a plane is about 50% out of, but that's not just out of two things. That's 50% out of all of the possible choices there, like dog, frog, horse, ship, and truck. It can predict a car 72% of the time, and so on and so forth. So these are the types of things that when you think about self-driving vehicles, they have to make these types of predictions. What is that thing in front of me? And you can use things like deep learning to make these types of predictions with varying degrees of success. Okay, I will stop there and turn it over to Emily.
Thanks, Keith. No, I think that's so great because I oftentimes find that people think that AI is just generative AI, and I'll talk about that. Of course, I'm going to start talking about generative AI today. So as many of you know, who are tuning into our amazing intro, I am the host of Generative AI 101, which is a podcast. I am not promoting it, but you can listen to it if you want, if you need little snippets of this information. So I think a lot of times we think about generative AI and we think about AI in general as ChatGPT, right? It's become this Kleenex of the AI space. And I'd love to kick it off with Keith because I'm here to remind you, AI is a very old field, and it's also something that is far more diverse and expansive than just ChatGPT. And if you listen, I did some episodes last week about Andreessen Horowitz came out with their top Gen AI tools. They do this about every 6 months because every 3 weeks, AI is changing. And so it's interesting to really see on that list where Gen AI has come from. So we think a lot about it in terms of ChatGPT, but I want to show you that AI is actually quite broad, even in the Gen AI space, right? So we have everything from text to text. We all go to ChatGPT or whatever large language model of choice you choose, and we give it some input and we get an output, right? It's a text to text relationship there, but it goes broader than that. We have text to image, so you can give a natural language prompt input. So give me an image of a raccoon surfing in space eating pizza, and it will give you some beautiful, interesting, vibrant image of such. Then we have things like text to music. So these are systems like Suno, if you've ever played with this. And I work in a higher education institution. I also consult with industry, and it's interesting because I like to tell people, you know, the use cases are so broad. So let's say you're trying to study for an exam, you're a student. You could actually use the text to music to create a song to help you think through and remember something for a test or exam. Or if you're in industry and you're preparing for a big presentation, you could use the same thing to remember some key points as you go through. Now it starts there, right? We all start with good intentions. And then eventually we're writing a song about like cowboy boots that drink beer and sing and dance, and it just like falls off the rails. And there's always fun in all of this too. Part of generative AI is really truly that creative human aspect, right? But there's amazing outcomes that you can do into your personal life, your professional life, your learning life from these tools. Now, text to audio is pretty straightforward. I oftentimes give the example of we've had colleagues and friends from other universities who are building incredible chatbots. We're just in a new era of chatbots where they're smarter, more intuitive, and more human-like than ever. And that adds on to the fact that we can also give them these really humanistic voices. So we could give a chatbot a voice of really anyone we want to, if you're familiar with character AI. And so I have a colleague at another university, and they had built this incredible tutoring bot. And so she asked her students to vote on what voice it should have. And to her surprise, they all voted Snoop Dogg. And so now they have a tutor that helps out with their students in Snoop Dogg's voice. And if you're familiar with systems like Speechify, you can actually assign different voices, and Snoop Dogg is one of them. So if you're someone who'd like Snoop Dogg to read all your web articles and emails, that is now possible through the magic of generative AI. And then, of course, there's text to video. And this is a really interesting space because video for a long time with AIs, of course, was clunky. It looked strange, the transitions were off. Even when OpenAI, makers of ChatGPT, introduced Sora, at first it was breathtaking. And over time, the transitions got strange. People's movements seemed more unnatural. There was a video where there was like puppies just kind of exploding out of each other like a strange Russian nesting doll. But they've gotten better. And again, I'll refer to that Andreessen Horowitz. It's a venture capitalist firm. They put out a top Gen AI tools every 6 months. And we've now seen 3 Gen AI video tools hit that list. So these tools are getting better by the day. But it doesn't stop there. Generative AI can do even more. So text to code, and this is a big one. This is where industry is definitely going to feel a shakeup. And we've seen a lot of companies like Meta come out and say, you know, they may not hire as many software developers. They might transition into tools that are going to be able to code instead of humans doing it. And we've seen tools like that, like Devin, which is a coding tool out in industry. It's $500 a month, or OpenAI's Plus account, which has an agent operator that can do some of that coding work. That's $200 a month. So we've definitely seen that. Other tools like Claude 3.7 Sonnet or 3.5 are excellent coders, and I'll talk a little bit more about that as I continue. And then we have things like text to 3D. So this is where I've seen some truly incredible things in industry and even in the classrooms here at UW-Stout. So we had a project last semester where we had local kindergarten students come down and pair up with our senior engineers. The kindergarten students were the clients, and they were able to communicate effectively to our senior engineers the perfect toy they wanted, okay? And kindergartners have the wildest imagination for their dream toy you've ever could imagine, right? And so one of my favorites that sticks with me was a tank helicopter. So there was a student who wanted a tank helicopter, And what we did is before we taught our students how to effectively prompt, and Dr. Cami Banger is going to take you through a whole thing on that, but how to effectively prompt into an image generation tool called Adobe Firefly, which is by Adobe, but we have Adobe products at our school, so all our students have access to them. And so we taught them how to effectively image prompt. So they took their student, their client, through an entire design process with them, and then they were able to effectively prompt a 2D image of their dream toy. So there on the screen was a 2D image of the tank helicopter, and you got to see the client's eyes light up and they are thrilled. But then we took it a step further. What we did next is we took that 2D image, we downloaded it, and then we entered it into a 3D image modeling tool, right? So we were able to make a 3D rendering, and then from that point, we could 3D print that tank helicopter. And I've really seen this happen in industry spaces too, where industrial design teams are taking really comprehensive designs that would take typically 6 months and making the design cycle down to 2 weeks. And this is where AI is truly impacting industry and reshaping what productivity means in many, many spaces. Then you have more traditional things like audio to text, audio to audio, and image to text that all play a role in the generative AI landscape. Now, you heard me say the word large language models, or LLMs, and you're probably wondering, what the heck are those? Well, large language models are advanced AI models designed to understand and generate human-like language. So everything that I've been talking about, from ChatGPT to Claude to Gemini and more, they can predict the next word or sequence in a text. And as Keith hinted on, it really depends on what they're trained on. So you can develop large language models that are doing text to text, and then we get into more advanced image generation models that are trained on mass amounts of images, so on and so forth. But it really does depend on the data and the training that's happened in those spaces. From there, I want to show you how AI learns, and that really focuses on data-driven learning. So AI improves through data similar to human learning. The example I always use is training an AI to recognize cats in photos. And I have a 3-year-old daughter. And it's been really interesting over the last 3 years how intertwined my life has been with AI and understanding supervised and unsupervised learning and reinforcement learning, and realizing that I'm watching machines do this and I'm watching my young daughter do this. So an example would be when my daughter was about 2, everything was a kitty, everything, right? Because there wasn't that differentiation of categorization in her brain that some things were actually a puppy and some things were also a raccoon. To her, everything with ears, a nose, and a tail was a kitty. And this is what I mean with how AI learns. Over time, you feed AI enough data, you give it supervised training or unsupervised training, categorization, reinforcement learning, where you're telling it yes, no, wrong, sort of right. And over time, it's learning. And we do the same things as parents to our children. So it's a great analogy I'd like to use with folks to try to make sense how we've really trained these machines. And it sounds very human-like, and it is, because we as humans apply our own properties, our own organic chemistry, if you will, into the machines that we build and that we make. So that's a great example of how AI truly learns. I want to just talk you through some of the main types of large language models. So the one, of course, everyone knows is OpenAI's ChatGPT. And then, of course, there is Claude by Anthropic. I have been truly smitten with Claude 3.7 Sonnet. I'm sure if you've tested it, you've been blown away as well. I find that everyone seems to know about Claude, but not everyone uses it. But the ones that do are like die-hard Claude fans. And I really wasn't that until 3.7 Sonnet came out, and I saw the truly incredible things it could do, from image model building to building really robust sliding scale data infographics. I mean, it's truly incredible what's happening there. Many of us know large language models or generative AI through Microsoft's Copilot, which has really been integrated globally into most business spaces. So you may have Copilot Enterprise, where you have it within your Microsoft Office suite, or you may just have access to the chat space online. Either way, it's a resourceful tool that's definitely beneficial. And lastly is Gemini by Google. Google has definitely been in the tech race for a long time and a major leader in this space. Their Google Gemini tool is truly impressive. Gemini 2.5 Pro that just came out, I believe, last week is incredibly impressive. Without going into too much detail, it has benchmarked incredibly well as a model, and I anticipate much more to come from Google as we continue. And like I said, this landscape is ever changing. I think every 3 weeks we get a new tool model upgrade. It's a wild time in the world of AI. So large language models are built through training on massive, massive data sets. This can contain all kinds of things, and I'll just pop to the next slide because I actually kind of like this one better for walking you through everything. So I call this the DNA of generative AI knowledge. So I always say generative AI has been trained on the whole of the internet and far beyond that. So anything you could think of, from Shakespeare to online recipes to the truly unhinged comments of Reddit, it's been trained on all of it. And we figured this out, I want to say 2 years ago. The New York Times actually figured that they could produce an entire verbatim article in ChatGPT of theirs. And that was a big deal. And I typically, in this part of my lecture, I'll ask, does anyone know why that was a big deal? So if you know, gold star for you. The answer is because the New York Times sits behind a paywall. And because it sits behind a paywall, OpenAI probably shouldn't have had access to that, nor should its model be able to reproduce that verbatim. But it started to give us a peek under the hood of what these models were truly trained on. And we started to realize it was everything. YouTube videos, Socrates, Plato, Reddit threads, your mom's strange recipe that was posted on Facebook. We don't know. It's everything. So it's a very interesting time that you can go to a centralized space and find so much content all in one row. What I truly love about generative AI is how it has helped me pare down instances of finding information. And one example I often use are recipes. So you want to cook something. I'm not a cook, but occasionally I get a wild hair that I'm like, you know what, I'm going to make chicken noodle soup tonight. I don't know how to make chicken noodle soup, right? So in the past, what we all do is we go to Google, right? And we search chicken noodle soup recipe. And what comes up is the top 10 links and probably some sponsored content. And you have to now choose your own adventure. Are you going to select the best chicken noodle soup recipe ever, award-winning chicken noodle soup recipe, the greatest chicken noodle soup? You get what I'm saying. Every URL has some impactful word that's drawing you in. So you click, you choose the adventure. And when you get in there, what you find is a whole biography of the author, right? It never starts out with just the recipe. No, 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 that'd be too easy. What you start with is this whole thing like, my father was a poor farmer in Oklahoma in the 60s. And you're like, I just want to make chicken noodle soup. So you keep scrolling. My family absolutely loves this recipe. No, 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 keep scrolling. And you're getting hit with ads and different images. And you're like, please just give me the recipe. And by the time you get to the bottom, you're not hungry for chicken noodle soup anymore. You couldn't care less, right? So you move on with your life. The point I'm trying to get at is generative AI, from a text generation, an image generation, a video generation, a code generation, whatever it might be, whatever your cup of tea is in this space, helps you get from point A to point B faster than you've ever been able to before, all right? And that is going to be kind of my intro to Gen AI for you folks. And I'm going to now kick it over to the very esteemed Dr. Camille Banger. Please, Camille, introduce yourself to us.
Hi. Hi, everybody. My name is Dr. Cami Banger. I actually teach in the Business Information Technology program at UW-Stout. So while Keith and his esteemed colleagues are the ones that are understanding the backbones and the infrastructure that goes behind these, what we do is figure out how we can use these to the best of our ability, because there's always new tools coming out. And I will refer a lot to this. I'm going to speak mainly on generative AI and the best ways to use generative AI, but it's going to mainly be, I'm going to focus on it as a tool, because it technically is a tool, another tool that we get into our daily lives. So I want you to think about this about when calculators came out in the 1960s. They made math easier, right? But you still had to know what to punch in. It couldn't predict what you wanted it to do. The same idea with generative AI. it needs good inputs. And that's where prompting comes into play. So we talk a lot about what is a good prompt, and that's actually what we're going to go through today in the cycle of prompting. Now, I consider myself an AI enthusiast, but I also consider myself an AI skeptic as well, because we are going to talk about the risks. You've heard Emily talk about it's trained on everything. So you have to be the detective essentially to know that the outputs that are coming out are actually what you want it to be. So a prompt is basically you telling the AI whatever you want, whether it's a question, a task, whatever. How you ask makes a big difference in what you get back. So getting good at prompting is really the secret to getting better results in what you're getting out of these tools. So prompts can be super simple or they can be detailed. So here are 3 basic ones you can try to boost your communication and productivity. And these are just examples. We could be here for days talking about all the different ways you could use generative AI, but here's a couple. So first, you can ask the AI to make something sound more professional. I use this on a daily basis in my emails. Sometimes I am a little bit more conversational. Sometimes I am a little bit too professional. So I'm using GenAI to help me sort the tone of what my email is. You can also have it help you summarize a report. I do that all the time. Sometimes you get lengthy documents and you're like, I need the key points. So I'm having it summarize those key points to save me time. Quick note, we will talk more about safety later on using these tools. It's really just being careful on what you are sharing with AI, because as Emily alluded to, once you put it in, they are learning from that. So we'll talk a little bit more about that towards the end. You can also have it create a checklist. Like if you're prepping for a client presentation, for me, prepping for this presentation, what are the key points that I want to ensure that I hit? So these are just a few ways AI can help make your life a little bit easier. Sorry, all my animations. So prompt engineering plays a huge role in getting good results, as I mentioned, from AI. So think of it like this. Using generative AI, and this is what I tell my students, like when we're first diving into this, think of it like you've hired a human assistant. I know it's AI, but we're hiring a human assistant. If you want great work, you can't just say, I need you to generate a report for me. Well, you haven't provided it any information. You have to give it clear guidance, share the right information, and provide specific instructions to that human assistant. You need to do the same thing with generative AI. So a good prompt does a few key things. It guides the AI's behavior, just like you would with an AI or a human assistant, because without it, responses can be very random or it can miss the point. It also improves quality, so clear prompts lead to that better, more relevant output that you're going to get. And it lets you steer the AI towards specific tasks, like summarizing, rephrasing, or even analyzing the sentiment of what you have your output coming out as. And it aligns the AI with your intent, because the goal is you want to get out of it what you need to help you be more efficient, more productive, whatever it may be, and avoid all of those inaccurate results. So this is best practices. So there's 4 key pieces to a good prompt. I use the quotes good prompt. So a well-written prompt usually has the role defined, the context, the instruction, and example. And we'll break these down in a little bit more relevance. The role really defines the tone you want it to have, the style, personality, whatever characteristics you want it to adopt. So for example, you could say you're going to be a helpful assistant or a confident consultant. I often use you're an academic advisor, a warm, friendly academic advisor, right? Because I have a lot of emails that come in a day from my students. But assigning this role makes the response more engaging and better suited for your audience and helps it adopt your tone. The context provides the background information. So again, thinking about that human assistant versus our AI assistant, you have to give them the same background. What is it that you want them to do and why? Like, what is the background? So without providing the understanding of the topic or theme, the AI might miss important details or respond way too broadly. I've seen too many people put it in a prompt and they're like, it didn't give me what I wanted, and they've given up. Okay, so that's why we're really focusing in on these 4 parts of the prompt. The instruction then is a specific task that you want the AI to perform. So, and this is really the core of your prompt. And clarity is key. The more direct you are with your AI, the better the AI can deliver. And then finally, you may want to provide examples. If you have certain formats that you want your prompt to come out in, like especially for a complex task or even for a simple task, if you have like an email where you want it to provide a nice greeting first and then provide some key points and then a summary and a thank you at the end, you provide that example of how you want that to come out. So when we're combining these 4 elements, this would be one prompt with these 4 elements. You're going to create that prompt that's clear, targeted, and much more likely to produce the precise, high-quality response that you want. So I'm going to go through each one of these and give you a little bit of example of each one of these. So first up is role. So if you think of it this way, we all wear different hats, right? Depending upon the situation. All of us have different hats. And when you're prompting with AI, you're asking it to wear a hat too. So think of the role as, what hat do you want it to wear? Plain and simple as that. So like in business settings, you can set the right role for whatever you need it to be. So example, you want to respond to a customer inquiry. You might want it to take on the role of a friendly customer service representative. So someone who responds warmly and thanks the customer for the feedback. But other roles, and again, I can't cover all of them because we would be here for days. Other roles could be a confident sales consultant. So if you're trying to close a deal, maybe you want more of a confident tone, or an analytical advisor, or even a project manager. It's really dependent upon what you need, but it's really key to set that role to tell them, what role are you acting in? It really helps set or for the AI to match the tone and style that you want. I know it's a small step, but it really helps whatever you are trying to get out of the AI feel more polished. Then context. And honestly, this one's a game changer when it comes to prompt engineering. Context, just like a human assistant, is what gives the AI the background it needs to really understand that the task that you're asking it to do. If you don't provide this, you're probably going to get too broad or misunderstood information coming back at you, because the AI is really guessing at that point if you don't provide that context. So in a professional setting, adding this context could be something as simple as this is a follow-up to our last week's strategy session where we discussed AI integration solutions, and you would provide that summary or that strategy information from that strategy session to give it, again, that context. That little bit of background helps the AI focus on exactly what matters, like summarizing key points from that specific meeting, and instead of, having it go off track, which we'll talk about in the risks that are coming up. So the skeptic in me. If you're sending out a project update, you might say this is a quarterly update on the project's current status. That way the AI knows to zoom in again on recent milestones, key deliverables, and not the whole entire project. You just want to focus on what's happening now. So bottom line, giving good context in your prompt helps the AI deliver responses that are sharper, also more relevant, and way more useful, and you spend less time revising them at the end. The next part is instruction. So instruction, again, very much at the heart of your prompt. This is where you tell the AI exactly what to do. I can't tell you how many times when I first started using ChatGPT, because that was my tool of choice at the beginning, where I put in prompts and it would give me this long essay, right? And it's like, I don't need an essay. I need something very concise, very short. So you need to tell it, what is it that you want? Do you want it to be 100-word response? Do you want it to be short, concise, 2 paragraphs? Or do you want it to be an essay? So being super clear with your instructions is a key if you want to get have the AI give you the kind of output that you're looking for. This is also the spot where you can get specific about things like, again, how long you want the response to be or what format you want it to be in as well. So for example, let's say you need an email that acknowledges a client's proposal. You could say something like, write a short, succinct thank you email acknowledging receipt of the client's proposal. So this way the AI knows, be brief, be polite, and to the point, and please don't give me a 2-page essay. You can even put that in there. Please don't give me a 2-page essay, right? The more instructions that you can give it, the better. Really, the main takeaway here for instructions, they need to be direct, they need to be specific, and leave no room for guessing, because what we'll talk about later is GenAI tools are really good at filling in the blanks, even though you don't want them to fill in the blanks on things. The next part then is examples. I will tell you, I don't always give examples in my prompt. It's really dependent upon what I'm doing. If there are specific things, a specific output that I want, like here is the format I want an email to come out in, like, dear recipient, thank you for meeting with us on this date. We discussed these 2 topics and we're looking forward to continue collaboration. I might provide that as an example. Or if I have an outline that I need help with creating, I may say, I'm doing research and I need an outline for chapter 1, chapter 2, chapter 3, chapter 4, chapter 5, and here is the outline for that. Because I have specific guidelines that I have to meet. I would feed that in for that, but it's really helpful because then you know exactly what your output is going to look like and you're not spending a ton of time reformatting it, that information. So when the task gets a little bit more complex, or if there are special conventions that you need to follow, maybe it's for a report or a status report, like, again, those would be great things to feed in. They're super helpful for the AI to really respond and align with your expectations, as well as any standards that you have to do that with. So those are the 4 basic parts of prompting, okay? Role, context, instruction, and examples. And that is all in one prompt that you would put out. So you truly are feeding it, because remember, AI, just like your human assistant, can't read your mind as much as we would love them to. They can't read your mind, so you do have to provide them as much context as you possibly can. So next we're going to look at some prompt examples of how this looks. So we kind of broke it out for all of these. These are a couple of examples of putting all of them together. So this one in particular is for a social media post, or sorry, this one's for, I have 2 that I want to show you, sorry. This one's for a follow-up email for a client meeting. So again, this is all in one prompt. So we're telling it that they're professional and courteous as the role. You're acting as a client relationship specialist. The context is you are writing a follow-up email, and we would provide key points that we would want to include in this email. We're also saying, from an instruction standpoint, write a 150-word email. Very important, so we don't get a very long-winded email that the client probably won't read. And then examples. I do have a specific example of a structure that I wanted to come out in, where we say, hi, client's name, include the date of the meeting, discuss the client's goals, and main topics covered in the meeting. So very specific in each one of those areas. So again, this example really incorporates all 4 of those key parts, and it's going to help us get a much better response from AI. This is the other example. I actually use this one quite a bit because I am doing my own social media content for our program at UW-Stout for the different social media platforms we are on. So in this case, from a role perspective, you are a social media marketing specialist. The context is you're announcing the launch of a new product. Ours would be, we have a new name in our program. That's what I've been using it for. The instructions would be, I need a 100-word LinkedIn post. Again, you can change that context depending upon what social media platform you are putting it in. And then I provided an example. I could even change this a little bit to say that I want a call to action or things like that, but really highlighting what we want to come out in the social media post. And what it does is it helps me generate a much better social media post than what I probably would create on my own, because I am not a marketer. I'm the first one to admit that. You'll see, though, in the context, I do say we would need to include information about the product and key features. But again, This is where I put out that skepticism and kind of the risks of this is that make sure that you are not posting any proprietary information or things that you would not want to share out in the internet world, right? The entire world, because these large language models and generative AI tools are truly learning from all of the data that is fed into there. We talk a lot to our students about making sure you don't post personally identifiable information, your date of birth, your social security, your eye color, your hair color, like really making sure that you are staying safe when utilizing these tools as well. So with that in mind, this is probably my favorite thing besides how do you write a prompt? What is the basic structure of that? Because you might and most likely will not get exactly what you are looking for on the first try. So we like to think of this as a wash, rinse, and repeat type of process where you're constantly refining and improving your output. So we already talked about the prompt, right? How to write that prompt. That's essentially the input. So you're going to take those 4 key pieces, create your input, and then you're going to hit enter. And you're going to get an output for that, whether it's text, whether it's summarizing data, whether it's an image, whether it's an audio, whatever it may be. The third piece, and I talk about this a lot, review is so extremely key in this because they can hallucinate. They can fill in the blanks that you didn't fill in. They can have misinformation in there. Again, think about it's pulling information from Reddit and Facebook and other social media platforms. So most likely there is going to be information in there that you may not want to include in there. So then it gets to the revise section. I will say on average, and I've been kind of keeping track of this, when I put an initial prompt in, I probably have to revise that prompt 4 or 5 times in order to actually get the exact thing that I'm looking for. And that's because I may have left out context. I may have left out a keyword like I want this concise. I don't want this to be a 2-page essay, or I may need to provide it an example, or I may need to feed it some more information. So really thinking about this, if you think about the 4 inputs of a prompt, think about the 4 phases of a prompt. It's kind of easy to think 4 and 4. Rinse, wash, rinse, repeat, wash, rinse, repeat, wash, rinse, repeat, until you get there. And now my favorite from the skepticism side of my personality is let's talk about the risks. I've already talked a little bit about these. It's a fantastic tool. Again, it's a tool. You are still responsible for checking the output, just like you would on a calculator. If you typed in 6 + 5, but you meant to type in 6 × 5 and you got 2 totally different answers, you'd be like, ooh, that's not right. And you would go back and revise that. It's the same thing with these tools that are out there. There are safety concerns, though, potential risks, and really some tricky spots that you need to keep an eye on. And it's really about just being aware of these challenges that will help us use these tools more ethically and responsibly as well. So I'm going to go through just a couple on here. I have way more. I could talk about this entire topic for an hour. I'm just going to go through a couple, but some of the bigger ones are misinformation, right? These tools can hallucinate. And if you think of hallucinations, you probably heard that term in your life. It makes up information. Just the other day, I was out Googling using the built-in Google AI feature, and I had asked it a question on when the graduate fair was for UW-Stout. Well, it gave me a date, and luckily that tool provides links where you can double check the information of where it pulled it from, and it pulled it from like UW-Washington. So I would have given if I wouldn't have checked that, I would have given my students the wrong information. They also plagiarize, as Emily mentioned. There are things that are being brought in and training these models that probably shouldn't have been doing that. So we have to be very careful about plagiarism, privacy breaches, and also bias. And it's in each one of these. So that's some examples for text generation, but it's also the same types of risks for language translation. The same types of things could be in there, but these tools have been used to translate language in quite a different ways. You really have to be double checking those. So using that rinse, wash, and repeat process, because they can translate things inaccurately. They can have misrepresentations. They can have biased translations. And again, privacy and data security breaches as well in there. So it's really, again, don't just trust what comes out. We still have to be very cognizant of looking at the data that's coming out or the output. A lot of people use it for questioning, answering. Same type of things apply. Hallucination. Hallucinate. Oh my gosh. It's towards the end, so it can hallucinate. There's outdated information, especially like when I'm looking for troubleshooting information. I used it to troubleshoot something in Excel, and it brought up something in the response from like Excel 2009. I'm not using Microsoft products from 2009, right? Like, so the troubleshooting did not align with what I was doing. So I had to double check that. And then I had to be more specific in my prompt. And it can also lack that contextual understanding, and it can provide harmful answers. Again, looking at that bias piece. Also, same type of thing for text summarization. And these are just 4 key areas that a lot of us are using these models. This is kind of how we've started using these types of models. I do want to quickly end with just a couple of other ways that I've used AI. I've obviously have it help me draft emails. Because I receive over 50 a day, and sometimes my brain is just fried and I might not be as professional sounding as I want to. I also, as I mentioned, I use it to create marketing materials for my program because I'm not a marketer. So I am training this to be my marketing assistant because that's not me. I do like digital marketing technologies, but I'm not a marketer. I don't do the content part of that. I've had students create their own algebra tutor through their own AI agent, and I've also created an AI agent for my son and I to learn Spanish together, which has been pretty cool. So there is so much out there. I encourage you all to have curiosity with these. Don't give up. Use some of the 4x4 prompting tools and continue to use them in an ethical and responsible way, because again, they can make mistakes. They're not perfect. So I will turn it back over to Emily. Thank you for your time today, and look forward to hearing from some of you.
Oh, thank you, Dr. Cami. That was phenomenal, as per usual. All right, Dr. Cami, Dr. Keith, thank you so much. Folks, you are all troopers for sticking with us through this very content-heavy intro to AI. You are all just rock stars. Everyone gets an A. All right. If you're interested in learning more about AI, you can reach out to us. Dr. Cami and I are available to teach you prompt engineering if your business or industry is interested. We also have prompt engineering on demand for beginners. We have AI for educators coming up online June 12th through July 9th. Then data storytelling with GenAI. So if data storytelling is something you need to master, you should probably be at that training, July 17th. And then AI implementation strategy starting July 24th if your business is going to be integrating GenAI, which it better be. If you want more upcoming professional development, you can go to uwstout.edu/prodev. That's uwstout.edu/prodev. And we also have a lot of great continuing education and conference services coming up, from conference and events planning, youth camps, professional development, customizing training, personalized enrichment, and more. If you have questions about GenAI or just want to do a training for your company or organization, please do not hesitate to reach out to me. I am happy to connect. Otherwise, with that, folks, I bid you adieu. Thank you to my incredible, brilliant co-hosts, and to all of you for attending. Have a great rest of your Thursday.